In this question, we're asked to use Henry's law constant to determine the amount of pH 3 that will dissolve in a certain solution of water. So let's look at the question. It says, at 25 degrees C, the Henry's law constant for phosphine, pH 3, in water is 8.1 times 10 to the minus 3 molar per atmosphere. Calculate the mass in grams of pH 3 gas that can be dissolved in 1,200 milliliters of water at 25 degrees C and a pH 3 partial pressure of 1.9 atmospheres. Alright, so this is basically what we're going to do. Well, this is basically a two-step problem. Okay, Henry's law relates the concentration, the molarity, of a gas in a solution to the pressure of the gas, in this case the partial pressure of the gas, over that solution. So we can use that to find the concentration, but then to find the actual mass, we have to essentially do a dimensional analysis problem to find the mass. So let's do it in two steps. First, concentration equals kH, the Henry's law constant, times the pressure of the gas. So the concentration of the gas equals the Henry's law constant times the pressure of the gas. Note that the Henry's law constant changes with changing temperature. We will not actually plug the temperature in anywhere in this equation. However, this constant is temperature dependent. So the temperature is a factor, but it's not directly in the equation. So let's take a look at this. The concentration equals the kH, which is given, 8.1 times 10 to the minus 3 molar per atmosphere, times the partial pressure of the pH 3, the phosphine, which is 1.90 atmospheres. When you do that math, you find that the concentration is 0.01539 molar. Now we have a dimensional analysis problem. Because we have 1,200 milliliters of water, or we're going to have 1,200 milliliters of solution, and we know, we want to know the mass in grams in 1,200 milliliters of this 0.01539 molar solution. This is something very similar to what you did in General Chemistry 1. So let's take a look. You'll recall that when you're using molarities to find moles, you have to have volumes in liters. So essentially, we're going to take the liters of the pH 3 solution. We're going to convert it to moles of pH 3, and then finally we're going to use the molar mass to convert it to grams of pH 3. So this is our plan of attack. Note you can't use milliliters, so you do need to convert this milliliters to liters. So divide by 1,000. So we have 1.200 liters of solution times, well, this means that we have 0.01539 moles of pH 3 is exactly equal to 1 liter of the pH 3 solution. And just for clarity, I'm going to put pH 3 here. So this is our relationship. So we want liters to cancel out, so we put the 1 liter of the pH 3 solution on the bottom, and the 0.01539 moles of pH 3 on the top, times, in the next conversion, we need to convert from moles to grams, so we need to use the periodic table. We put the 1 mole of pH 3 on the bottom, and if you add phosphorus and 3 hydrogens, you get 34.00 grams of pH 3 on the top. Multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. I will note that since the Henry's law constant is 2 sig figs, this is the sig fig we care about here. This is a measured number, so this is the answer is going to be 2 significant figures, which in this case is 0.63 grams of pH 3.